a couple other things here. One thing is a conditional transition. So you'll notice that over in your palette, there's a thing called a branch. And a branch allows you to have a have transition which then will split to go to one of two places. So for example, you may have a branch here, and so we could drag it over, and this branch will have a certain outcome. So some part of the time it will go one way, some part of the time it will go another way. Okay, so perhaps, for example, we'd have a recovery from infection, and some part of the time it will go back, to the susceptible state, and some part of the time maybe it will go to a death state. We could drag in a final state here, and we'll connect on this transition. We'll connect the other part of the branch to this. So under some conditions, the person will recover. Other conditions, they will die. And what you'll see is that if you look at this branch, you can have an action when you come into the branch. But you'll notice the transition out, you can specify for the transition out, is that the default transition, or is it only going to be taken with a true transition, under a certain condition? And the same thing for these others. So one of these can be default, and like we can make the one that goes back to susceptible the default transition. And the death transition, maybe we will have a chance of 0.1 or something along those lines. So we could have, draw a uniform from 0 to 1, and if it's less than 0.1, then we will go to this death state. Okay, so we're sort of rolling the dice, and if we get unlucky, if it's between 0 and 0.1, we will go to this state. So you'll notice what it is, I set this as the default out of this branch, and I set this guy based on this condition, uniform of 1. What does that do? What does this uniform of 1 do? It draws a random number between 0 and 1. And if it's less than 0.1, then it will go to this death state. In other words, there's a 10% chance that we'll go to the death state. Now, there's actually a nicer, cleaner way of doing it. I was using a primitive we had used before, but you can actually do something called random true, okay? And you just give it a probability, 0.1. And it will either return true or false, okay? And then we'll go to a death state. In the death state, I think what we should do is we should color the person's color black, okay? The black. Now, later we'll talk about how you actually delete people from the model. And we'll see that, and maybe I'll do that for just a minute. But we can run this model. And what, too many defaults. Okay, I have 2 exits from this that are default. Let's make sure of this. This should be condition, okay, yeah, and this should be default. Is there another one here that I'm missing? So let's go look. This is in person. I'm going to go look over here, state charts, infection state chart. Oh, look at that. It's a transition 1, transition 2, and then there's a thing called transition. I should really name them something better. This is called infection. This is called, so we should call this something like recovery. Let's call this, death. And we'll call this one, beyond infection or something like that. I'm like a better term for it. Okay, so now we have these, and we should be able to now run the model. I'm not sure. I didn't see any problem with the transitions, but okay, there we go. And now what we should see is that occasionally, okay, These ones are, now they're occasionally dying. See the black? They're becoming in a black state. So they're occasionally recovering. Now here they're getting reinfected very quickly because we've made it based on aging, and their age is going up, and so they get reinfected quicker and becoming black over time. Here, what we've done is we've had a little branch which represents conditional transition within our model, and we've had an exit point, which we might associate with death. Okay, we can have parallel state charts very readily in AnyLogic. So you might have said TB, diabetes, tobacco use, and you're in exactly one. The person will be in exactly one state. The agent will be in exactly one state with respect to each of these state charts at a given time. So they might be in a particular diabetes state, a particular TB state, and a particular tobacco use state at a given time. You notice, incidentally, that this is a little thing that keeps track of the time since they quit. You could have the amount of time that they, number of cigarettes they've smoked over their life, or what have you. Okay, I want to make a delineation of this from classic compartmental or SD modeling, where we have a population divided according to state. For an aggregate model, stocks and flows, individual states are discrete, right? So we have susceptible, infected, recovered, for example. And that's very similar to what we can have here. However, here, one state within a given state chart is exactly active at a time. We don't, it's on a per person basis. So a person is either in one state in a state chart or another state. For parallel flows, where we have different state charts, we don't have to, in an aggregate model, we would have to consider, for example, susceptible with respect to seasonal flu and susceptible with respect to H1N1, infected with respect to one and susceptible with respect to the other, all combination. Here you have two neatly defined susceptible, infected, recovered with respect to each one independently. And similarly, instead of considering all possible combinations of diabetes and TB within stocks, for example, you could have two parallel state charts that neatly separate the two out. And we can keep track of how long an individual has been in a state and report that as an aspect of their history, or adjust the transition rate accordingly. And that is very notable because in general we don't have that option. Okay, here we go. This is an example, yes, of well, adjusting